This is the screencast for section 2.2, example 1. Finite limits as x approaches infinity. Infinity is infinite. Finite refers to the value that the y's are approaching. So a horizontal asymptote, as you have seen in pre-calc, basically means you have a horizontal line that both ends approach. Well, our definition is actually that a horizontal asymptote can exist when x approaches positive infinity or x approaches negative infinity. So you'll see some examples where the right side will have one horizontal asymptote and the left side will have another horizontal asymptote. Right now we've got f of x equals 1 over x, so just as a quick review, graphically we can look at this as the limit as x approaches negative infinity. So as we go all the way out here, the y values are going to approach 0. As we go all the way to the right, so the limit as x approaches positive infinity of 1 over x is also 0. So there's your horizontal asymptote, which in this case is the same on both the left and the right. Now we look at the vertical asymptote, just for review. The limit as x is approaching 0 from the right, the y values approach positive infinity, but as x approaches 0 from the left, our y values are going to approach negative infinity. So that's kind of a graphical look at that. So in other words, if we have the limit as x approaches infinity of 2 plus 1 over x, graphically, that's going to be the function 1 over x with a vertical shift up 2. So that horizontal asymptote isn't going to be at y equals 0 anymore, it's going to be at y equals 2. And I can tell you that the limit as x approaches infinity of 2 plus 1 over x graphically is going to be equal to 2. You could also look at that algebraically, so the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 1 over x, and since I know that from this graph over here, that's going to be 0. It's 2 plus 0, which is 2. And then numerically, you can look at this as if I plug in values for x that get bigger and bigger and bigger, so 2 plus, let's say, 1/10 would be 2.1. 2 plus 1/100th, so way out on the right side, is 2.01. 2 plus 1/1000th, 2 plus 1/100,000th. Eventually, you're going to plug in bigger and bigger and bigger numbers for the denominator, and that value is going to approach 0. So you're just taking 2 plus 0, which is 2. Now let's look at an example that's got two different horizontal asymptotes, one to the right and one to the left. We've got f of x equals x over square root of x squared plus 1, and we're going to use the graphs and tables to find the limit as x approaches infinity and negative infinity, along with identifying all horizontal asymptotes. So graphically, I can look at this and say, okay, my values as x approaches positive infinity looks like the y values are going to approach 1. And if we go out to the left, I don't know why I put this in a different window here, but I did. If we go out to the left, the limit as x approaches negative infinity is going to be, looks like -1. And then numerically, I set my table so that my starting value was 0, and I think I went by some random number, I don't know, really high interval. And we're getting larger and larger and larger for x's, and you can see the y values are going to hang out at 1. Now, of course, these are rounded. They're not exactly 1, but they're really, really close. And then same as x approaches negative infinity. These values coming in from the left, or excuse me, going out to the left, also approach -1. Now, what does that mean, though, algebraically? How can I look at this, not knowing what the graph is, and figure out what its limit is? Well, from pre-calc, we know that in order to find a horizontal asymptote, you're going to look at kind of the degree in the numerator and the degree in the denominator. In the numerator here, we've got degree 1, and in the denominator, we have a degree 1 as well, because it's the square root of x squared. So a simplified version of that degree is still 1. So really, I'm trying to simplify x over square root x squared. I'm looking at the first term when I plug in positive infinity and negative infinity. Of course, we're not plugging that in, but when I think about those values, I'm wondering what's going to happen to x over square root of x squared, these first terms. Because in the grand scheme of things, if I plug in 1,000,000 and I square it, adding 1 isn't going to make very much difference at all. So that plus 1 is kind of insignificant. So if I do plug in values that get bigger and bigger and bigger towards positive infinity, this is going to simplify down to a positive x over square root of x squared, which is still positive, so positive 1. This will reduce to positive 1. However, the limit as x approaches negative infinity of f of x, the numerator is going to be negative. The denominator is going to stay positive, so that's going to simplify to be negative 1 this time. So I have two horizontal asymptotes. I have y equals 1 and y equals negative 1. So let's do number 5 without graphing whatsoever. The limit as x approaches positive infinity of f of x. Okay, so in the numerator I have degree 1 and the denominator I have degree 1, so I'm trying to simplify 3x over the absolute value of x. So if I think about what happens as x approaches positive infinity, that's going to be a positive 3x in the numerator, because I'm plugging in positive numbers, and a positive absolute value of x in the denominator, so the x's would simplify and I would get positive 3. However, the limit as x approaches negative infinity means that I would take a negative 3x over, the denominator is still going to stay positive because of those absolute value, so that would be negative 3. So identifying all horizontal asymptotes, I've got two of them. I've got y equals 3 and y equals negative 3.